So we're glad to have Professor Robotic from MIT. Well, Russ kind of completed his PhD in MIT in 2004. He stayed there for a year for a postdoc, and then MIT would let go of him, so he joined there. As an assistant professor. Now he's an assistant professor there. So he's been working on movement planning for robotic systems. A lot of work is on under-actuated systems. So he's going to be talking about some algorithms for feedback and planning using some of the new thinking techniques that he has from control systems and other places he has kind of found quite useful.
Thank you very much. Thanks for having me. So, mostly I'll talk about algorithms. I'm going to try to do something on the board. So you can't see that on the board. I just do the little board, but hopefully that'll work. But I should start with just trying to describe to you the kind of experiments that I care about trying to design controllers for it. And you'll resonate with the first example because you guys all seem to build ornithopters around here. But we also got passionate a few years ago about building robotic birds, right? So I am a computer scientist first. So we had to build a bird that was big enough to carry a PC-104 stack and a lot of instrumentation. And then it quickly grew to being a 2-meter wingspan ornithopter. It's got a titanium gearbox just to handle the loads, the wing loading that we were putting at it. It had a breakaway beak that broke away right before we took the picture. It's got some, we designed it all the failure modes and everything. But this was just an example that we built to try to understand whether we could start studying the problem of control for these really beautiful, interesting robotic birds, right? So this is the first time it ever flew. I like to show it because everybody's super excited that it finally stayed up, right? And then really worried because it's going to hit the buildings, we have to turn it off, hit the trash can. But that was sort of the very first hard-earned flight of our autonomous ornithopter. So I care about birds. So I like the bird scale ornithopters because birds just do amazing things. So this is a goshawk that can fly through forests. It's the predator of the forests. And they're just beautiful to watch. They're just amazing. You don't see any UAV that can do these kind of things. Watch how rock steady his head is as he goes through these obstacles. All right, and then this next clip, he's going to fly through a tube. It's a little hard to see, but he's going to fly through a tube that's about the same size as his body. And he does it basically at full speed. Right? It's so pretty. And then you notice actually he uses his legs too. He's got a little multi-modal locomotion going on there. So basically, you can summarize the goal of our research. We're just trying to do that, right? To give you another example from the other domain, well, let me get more specific, I guess, with the aerial labels first. So one of the problems that we've taken, I guess, to fruition in the